All right, here we go. So, lesson 2, we're still talking proportions, we're still talking ratio, kind of like rate. This is another form of ways to do ratios or ways to use ratios. It's called scale. And you might find scale certainly on a map. You might find scale when you're working with models or model cars and things like that, or when you're actually drawing pictures on your page. Uh, a much smaller version or a much larger version than the actual real life thing. So here I got a picture of, I'm pretending that the guy on the left, real life Mario, is that big. Now, picture this on the smartboard, he would be much bigger, right? So typically that's the size of Mario, I would say. And then the little guy on the right, that's a drawn version of Mario, Paper Mario. So if you look and I say, what's the scale being used here? Well, the large real life Mario, as you can see, I just stuck a ruler there to help us, is 10 units, whatever it is. Call it centimeters maybe. But the paper version, little Mario, is 1. So really, the paper is drawn on a scale of 1 to 10. 1 centimeter on the paper represents 10 in real life. Okay, the first number is always that. The first number is always the paper, the drawing, the model, okay? And then the second number is always the actual, the real life thing, okay? So here's an example of uh, where we can use this, right? Think of a model car being made in a scale of 1 to 75. It gives you the fact, and I've color coded this just for simplicity. If the model is 6 centimeters long, then how long is the real life version of the car? So here's your ratio. And remember, I think I told you before, I like using fraction notation for ratios a little bit better than I do like using the colon, but that's up to you. You can do whatever you like. But I would say let's always do this, okay? Always do the drawing or the model compared to RL, stands for real life, okay? So I could say this is the model or the drawing and comparing to real life. The numbers are given 1 to 75, okay? And 1 to 75 is what the scale has been listed. Then the model car is 6 centimeters long. Okay, so the 6 needs to go here or it needs to go there, right? There's only one of two spots to put it. You have to decide what is it that I've been given. And what I've been given is the model measurement. The model measurement is 6. Therefore, the 6 needs to go up with the model measurement. Okay, it has to be compared to it. That's the only tricky thing with scale here, is deciding where that third number goes. Once you figure out how that third number goes, or where that third number goes, we just need to figure out the unknown. And kind of like unit rate, it's really beneficial in that one of the numbers is 1. And you can turn 1 into anything. That's a real simple relationship, right? So you're thinking about, I'm needing to figure out this unknown. How do I figure it out? Well, it's on the right and it's on the bottom. So I'm either thinking about, um, how does 1 become 6? Because 75 will become that question mark the same way. Or how does 1 become 75? Because 6 will become that question mark the same way. All right, this is just a three number relationship. Fourth is unknown. So let's sort it out. It's really not that difficult, guys. You know how to do these things. So using that number 1 is really a bonus. I'm going to pick going to the right. Okay, I'm going to say times 6 times 6, and these guys are a little too thick. I got to change the thickness of every single color I pick, apparently. Okay, times 6. 1 times 6 is 6. So 75 times 6. Well, if you don't know that, you use your trusty calculator, and then you make sure that it's reasonable, and you go 450. All right, so therefore, the real life version of the car is 450. Now, 450 watts, right? We have to go back into our question and pick out the unit of measure. that's been used, centimeters. Therefore, it's 450 centimeters long, right? And now what do you do with that? Maybe more realistic, represent it maybe in meters, right? Since there's 100 centimeters in a meter, we divide by 100 and we say, okay, it's about 4.5 meters. All right, so there's a model car. It's 4.5 meters long. We could have a scale that's written in the reverse order. Notice that the 3 is larger than the 1. In the one before, it was a 1 to 75. Now it's a 3 to 1. It's still the same deal. It's still the fact that the drawing is the first number, right? Come on, drawing. The drawing is the first number, and the real life is the second number. So it's a 3 to 1. That means it's like a microscopic thing, right? It's a very small item blown up onto the page so you can see some detail. They do this with, in biology, show this certainly right now when they're talking about this coronavirus, they're trying to show you the virus and you see a way bigger version of what the virus really looks like. That's on a reverse type scale, right? Now this is 3 to 1. I'm sure the coronavirus is like, 200 to 1 or 500 to 1 or something really large, okay? So that we can see the detail. We don't need that for here. This is a very small ant. It's drawn on a 3 to 1 scale. If the ant is drawn on the paper, there's the key, at 6 centimeters long. Again, the 6 has to go somewhere, top or bottom. It's drawn on the paper. There's your clue. It's drawn on the paper. It's not the actual. So the 6 goes there. And again, we figure out our relationships. They're easy. How does 3 become 1? Divide by 3. How does 3 become 6? Multiply by 2. So multiply by 2 to the bottom and we get 2. So therefore, the ant is 2 centimeters long in real life, or actually, or whatever, right? They use the word actually a lot too. Okay, so that's scale, and you can use it. You can use it for models or pictures, or you can use it for maps. Let's look at this one. Now maps, they always give you the ratio. It's always the same unit of measure. You got to remember that, right? I mean, on some maps you might see 1 centimeter on the map represents 6 kilometers on the ground, but they would give you both of those units of measure. They wouldn't just say it's a 1 to 6, right? If it was different units of measure, 1 centimeter, a kilometer, and a centimeter are different. So when you see it this way, 1 to 600,000, they're in the same unit of measure, whatever it is. So if you're going to use centimeters to draw on your map or to measure with your ruler, then it's going to be in centimeters. Okay. So again, map distance compared to real life. You always have to think of that first number is the representation of the real life thing, and the second number is the actual. 1 to 600,000. Okay. These numbers get big, of course, but we can work through it. The actual distance between two cities is 30 kilometers in real life. Okay, so there's your first thing. If I didn't give you this hint down here, you'd have to figure this out, this conversion. Because one of them's in centimeters, right? We're not going to measure a map in kilometers. Think about that. We're going to use centimeters. So we need to convert anything they give us outside of centimeters. We need it to be converted back into centimeters. So if they said it's 30 kilometers, remember the stairs when we started our measurement unit, and we have kilometers way up there, we got meters in the middle, we got centimeters down here. You got to think about how we can convert kilometers to centimeters. All right. So the fact that it's 3 million centimeters, 30 kilometers is 3 million centimeters. We have that number 3 million. It needs to go somewhere. It's got to go on the top. It's an actual map distance, or it goes on the bottom. It's an actual on the ground distance, real life. And it says the actual distance. We go back and we read the actual distance between the two cities is there. Okay, well then that's a real life thing. So we go 3 million on the bottom. And we look for our relationships. Right? There's always relationships. How does 600,000 become 3 million? A little bit, I don't know, maybe more difficult than we want to deal with. It's not that hard, but why don't we think about the other one where 1 becomes 600,000, right? Or how does 600,000 become 1, I should say, because we're going up, right? We're trying to find the upper number here. So how does 600,000 become 1? Divide by itself. Divide by 600,000. Okay, so 3 million divided by 600,000, what's that going to be? It's not actually that difficult if you think about it. Let's do some canceling. Cancel a 0, 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 cancel 0, cancel. Now when I say cancel a 0, I'm dividing each number by 10, right? That's canceling zeros. There's another 0. There's another 0. Okay, so this really becomes what's 30? Oops, ran out of room on my tablet. 30 divided by 6. It's going to be the same thing as 3 million divided by 600,000. Well, that's 5. All right, 30 divided by 6 is 5. So therefore, the distance on the map, distance on map, I know you guys can read my writing, is 5 centimeters. Okay, and that's how we'd work with these numbers on maps. Okay, so we have actual models, we have pictures, we have maps. They're all scale related. Here's another question there, a map question. Here's another ladybug drawn bigger than it actually is, right? A 5-to-1 ratio. Let's look at that one quickly. Ladybug's actually smaller in real life than it is on paper. Then the scale is written as a 5-to-1. Notice that number 5 is the bigger number, 5-to-1. So if on my drawing I have a ladybug that ends up being 15 centimeters long, and I stuck those rulers together because I didn't have one long enough, we said it's 15 centimeters long, then how long is it actually in real life? Well, on the drawing, it's 15. So the 15 needs to be compared with the drawing number. Okay, and then we solve the unknown. The unknown is going to be what? I think you can see what it's going to be. 5 times what is 15? So 1 times 3 is going to be 3. So therefore, the actual ladybug is 3 centimeters long. That's a pretty large ladybug, actually. Think about it. Well, maybe they're getting bigger these days. Okay, there's some questions. Scale of the map is is 1 to 90. Measure the picture, find it. So this is probably a question in your book, actually. Let me see. Yeah, this is actually the question I'm going to ask you to do is from page 59. This is number 1, so I'm giving away number 1. So here's, I'm going to write this down for you. Page 59 and 60, numbers 1 through 9. I'm going to ask you to do. This is number 1, A. So let's do this together quickly. So the scale, it's actually a little car, a little yellow car that you're going to measure, right? And once you measure it, you'll find out that it's 5 centimeters long, right? If you don't see the 5, it's because you didn't measure it. Okay, looking at the picture in the book, it doesn't say it's 5. I've measured it. I know it's 5. I know the scale is 1 to 90. That's what they give me. So the picture, now I've put these guys in the other ratio form. I could have written it this way too, right? 1 to 90, picture versus real life. I'll write it both ways, okay? So picture versus actual or real life here is 1 to 90. The 5, where's it going to go, right? Does the 5 belong here? Is that a picture measurement, or is 5 an actual measurement? You decide. Where does the 5 go? I think it goes there, doesn't it? Okay, so if it goes there and it goes here because it's a picture, what's the relationship? Right? How does 1 become 5? That's the easiest one I can see. That's a times 5, right? 1 times 5, so therefore 5 times, or 90 times 5 or 90 times 5 is going to be what? That's that same one, that 450. I think I used this example already, that 450. So therefore, the car in real life is 450 centimeters long, which we could convert to 4.5 meters. Okay. The second question is 65 to 1 scale. That's a much bigger picture than it is in real life. It's 65 times larger on the picture than it is in real life. So where does the 1.3 go? Is that a, what does it say? Measure the picture. So we measured, these look like little pills or something. I don't know. Uh, find out that it's 1.3 centimeters long. That's a measurement of the picture. So where does the 1.3 go? Is that a picture measurement or is that an actual measurement? I measured the picture. It's a picture measurement. Therefore, the 1.3 must be compared to the 65. It might be a little bit counterintuitive because 1 is so close, 1.3 is so close to 1 that you might put it versus the actual. Don't get fooled by that. Read the question, read the description, what it's telling you, and then decide where the number goes. Okay? Now, how do we solve this one? Well, I don't know. We have a number 1 over here. That's a nice thing to have. How does 65 become 1? How about that? That's easy, because 1.3 is going to become the other number the same way. Well, 65 becoming 1 is a division of 65, right? Divide by the same number. So divide it by 65. So this one's got to be divided by 65. And that's going to be really puny, actually, right? I'll have to erase this out because I won't have room to put this whole thing in here. It's going to be really small. 1.3 divided by 65 is going to be 0.02. And what does that mean? 0.02 watts. Go back, find the unit of measure that was used, and you go, oh, it's in centimeters. Okay, therefore, I don't know what it is. The cell, perhaps? I don't know what it is. Cell is 0.02 centimeters long in real life. Okay? That's it for the lesson. It would be just like I was standing in front of you there in our classroom, except I wouldn't have any people sleeping. Well, maybe you're sleeping, I don't know. And I wouldn't have any people putting up hands and saying, I don't understand something. But the good thing about these types of lessons, if you don't understand something, I mean, go back, rewind, go back over it, find a Khan Academy video perhaps to support it, or post something into discussion after I put something up on our feed. Or if all else fails, just email me and I'll try and sort it out. Okay, or we'll figure it out somewhere. Anyway, oh, there's an alarm. What time is that? Okay. Anyway, so page 59 and 60 from the Math Makes Sense textbook. Hopefully you all have it by now. Numbers 1 to 9. That's your work, and that's going to be due on Friday. Okay. Thanks, guys. Have a great day. Bye for now.